Welcome back to another M&S tutoring video, and in this video we're going to be learning about ionic bonding. Ionic bonding is the bonding between a metal and a non-metal, and ionic bonding occurs when elements want to become stable. Becoming stable to an element is having a complete valence electron shell. So this is why some elements might give or take electrons to become more stable in the other hand. Metals usually tend to lose electrons, which is why a lot of metals have a positive charge. And non-metals usually tend to gain electrons, which is why they usually have a negative charge. The reasons why these metals like to lose and to gain is because it's a lot easier for a metal to lose one electron than gaining, per se, 7 more. And it's a lot easier for a non-metal to gain one electron to complete its valence electron shell rather than actually losing 7 of them to complete the valence electron shell. And something that attracts these electrons together is the electrostatic element that's involved when a metal and a non-metal technically go to bond. So let's begin with looking at a sodium and a chlorine example of ionic bonding. So in this case we have sodium, which is in this case it's a non-metal, and we have chlorine, which is we have sodium, which is a metal, and we have chlorine, which is a non-metal, right? So when you're looking at this, the first thing you have to do is realize which one is giving and which one is taking. Since chlorine is the non-metal, we know that chlorine will be taking, per se, any electrons that sodium is willing to give, meaning it will get a negative charge, right? We also know sodium is a metal, which means it will be giving electrons, right? Per se, giving it a positive charge, right? So after we have clarified that, what we have to do is we have to draw the Bohr-Rutherford diagram for both sodium and chlorine. So first of all, let's start with sodium. So sodium, let's start with the innermost shell where the protons and neutrons are. Like the Bohr-Rutherford diagram, you don't have to label the amount of protons and neutrons, because in ionic bonding, you're really looking at more over the electrons rather than the protons and the neutrons. So instead of 11p and 12n, which is usually the case for sodium, I'm gonna write, in this case, I'm just gonna write the element name. I'm gonna write Na, right? And I know that it has 11 electrons because 11 is the atomic number. So in my first shell, I'm gonna have two electrons. First shell, I'm gonna have 1 and 2 electrons, and the second shell, I'm gonna have 8 electrons. Right? So I'm just gonna quickly draw 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, technically, we still need one more electron to complete the Bohr-Rutherford diagram for sodium. But since sodium is willing to give that one electron to chlorine, what we have to do is we have to draw a bracket around sodium, right? And give it a charge of +1. This means that the electron is still there, but to be in its stable state, sodium does not really consider that electron in its outer shell because it's willing to give, right? So this is the diagram for sodium. Now for chlorine, what we have to draw is we have to actually draw the chlorine Bohr-Rutherford diagram in the same way. So we're going to draw the chlorine diagram. It's like this, C and L. And now we're going to draw the different valence shells, the electron shells. And chlorine has 17 electrons. So in the first shell, I'm going to draw 2. In the next, I'm going to draw 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw my last valence shell, right? And I'm going to draw all 8 electrons. Chlorine does not have all 8 electrons in the valence shell, but since it needs it needs one more electron in its valence shell to complete it, I'm going to draw that one more electron. And you'll begin to see why that electron comes from magnesium, or sorry, in this case, sodium, right? So right now on the outer, I have 7, right? And chlorine needs one more. So instead of actually putting another dot, I'm gonna put an X. This X shows that the electron comes from sodium. So I'm gonna do the same thing. I'm gonna make a bracket around chlorine, right? And then I'm gonna put -1, right? Because it gained one electron. And that's all it is. You have just drawn the ionic bonding diagram for Na and Cl. Now that you have the ionic bonding diagram, all you have to do now is you have to name the metal, or name the element, or name the bond. Sorry, and all you have to do for that is you have to write the metal first. So in this case, the metal is sodium. So you have to write sodium, and then you have to follow it with the nonmetal, but change its ending to "ide." So instead of chlorine, you change it to chloride. And here we have the bond formed. It's called sodium chloride. So now let's look at another example, a harder example in this case, with oxygen and aluminum. So oxygen and aluminum are not really the perfect requirements to fulfill each other's valence electron shells. So in this case, what we're going to do is we're going to look at how many electrons the nonmetal needs, which is oxygen. So first of all, I'm going to identify the nonmetal. So since oxygen is the nonmetal, it's going to gain a negative charge. And since aluminum is the metal, it's going to gain a positive charge. Now that I know that, I'm going to begin to look at how many valence electrons aluminum has. Since aluminum has 13 electrons in total, 2 being in the first shell, 8 being in the second, and 3 being in its last valence, I know that aluminum needs to get rid of 3. So I'll give it a charge of +3. Oxygen, on the other hand, has 8, which means it needs 2 more to complete its second valence shell, because there's 2 in its first shell and 6 in the second, so it needs 2 to complete it, right? Now, what we have to do simply is we have to multiply 3 by 2. And when we do this, we get 6. And what this means is that's how many electrons you would need to sustain both aluminum and oxygen. So in this case, what we're gonna do is we're gonna see how many aluminum and how many oxygens we need. So oxygen needs 2 to fulfill its valence electron, and on the other hand, aluminum can give away 3. So in this case, if we have 3 oxygens, right, you would need 6 electrons to fulfill all of the valence shells. And if you need 6 electrons, 6 is a factor of 3, right? 3 is divisible by 6. So we know that we need 2 aluminum, and now we need 3 oxygen. So we can begin to draw the oxygen. And I'm going to show you another way you can do the bonding diagram. There's 2 different ways. So first of all, we're going to draw the oxygen atom. So we have O, and over here, all we're going to do is we're going to draw the Lewis dot diagram for oxygen. So we have 1, 2, over here, and there we go. So we have 1, 2, 3, 4, 5, 6. We have 6 for oxygen. We're going to continue to do that for 2 more oxygen, because we now know that you need 3 oxygen and 2 aluminum, right? So now that we have done that for 2 oxygen, we need to do it for the third one, giving us 3 oxygen atoms. Now what we have to do is we have to actually draw the aluminum atoms the same way, just with the valence shell. So I'll draw the aluminum, and I'll draw the 3 valence shells. I have 1, 2, and 3, and I'll draw the second aluminum, and I have 1, 2, and 3. Now all I have to do for this diagram is to is to draw an arrow from one of the aluminum electrons to the oxygen electron. So all I have to do is place the aluminum electrons towards the oxygen open spaces, which is quite simple and straightforward as well. And there we go, we have another bonding diagram for aluminum and oxygen. So that's the end of the video, guys. I really hope you learned something new about how to name metals. Oh, sorry, we forgot to name our bond over here, oxygen and aluminum. If you notice, the chemical name for this would be Al2. Remember, we have to write the metal first, and O3, right? We named this simply because there is 2 aluminum and 3 oxygen in order needed to form the bond itself. So we would just simply name this aluminum, because we write the metal first always, aluminum oxide, right? Because we changed oxygen's ending to IDE. So again, that's that. Now it's the actual end of the video, guys. I hope you learned how to form ionic bonds with both metal and a non-metal. If you have any comments or concerns, please feel free to leave it down in the comment section below, and I'll get back to you as soon as I can. Other than that, thanks for watching, guys.